Hello everyone, today we'll study about the trigonometric functions. So here I have a slide share for you regarding trigonometric functions. So basically trigonometric function is based on the triangles and its measurements. So here it's goes like this. Yeah, so trigonometric function, a mathematician know how to solve the problem but he cannot solve it. This is a quotation for you. And then my second slide here is angle. So can you please tell me what is angle? Angle is like there is two types of angle, degree and radians, as I mentioned over here. So degree is a unit of angle that can be 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, or 30 degree, 60, 90, and so on. So the degree is not the temperature that we're talking. Degree Celsius, 5 degrees, 7 degrees Celsius. I'm not talking about this. I'm talking about the angle, which made by like lines from its base, right? So yeah, radian. When it's so here radian. See the radian. This radian is also the like unit of SI unit. It's a standard internationalized unit, right? So this is also a unit, and yeah. So it's example like pi, 2 pi, 3 pi. It's radians, right? So it's not I'm not talking about the pie chart. We're talking pi. This is not pi. This is a mathematical pi. It's a like symbol pi. So the next slide here is relationship between degree and radians. So tell me what is the relation between degree and radian. So you know that you have several times heard that pi radian is equal to 180 degree, right? So if something like if something like pi radian is equal to 180 degree, then 1 radian will be how much? Pi will be divided. So 1 radian will be equal to 180 degree by pi, right? Yeah, here pi will goes down. So same here, pi radian is equal to 180. 180 is 180 by pi. Same reciprocal to 1 degree will be equal to pi by 180, because 180 degree is equal to pi, right? So 180 into 1 is equal to pi radian, right? So here we transpose this 180 to denominator of pi. We get 1 degree is equal to pi by 180 radian. So this is a relation between radian and degree. So the next slide here is trigonometric functions. So tell me what is the trigonometric functions? Trigonometric function can be a function having sine, cos, tan, and this all trigonometric ratios, right? So first of all, we will solve, before knowing about trigonometric function, we will solve about the formulas. So the first formula and the most basic formula is sine square theta plus cos square theta equal to 1. This can be solved using Pythagoras theorem. So you know that Pythagoras theorem is a hypotenuse square is equal to the sum of the square of other two sides. Adjacent, or we can call this opposite or adjacent, right? Here I write perpendicular and base. You can call it adjacent and opposite. So using this Pythagoras theorem, we can solve this first formula for the trigonometric functions. So if we have this Pythagoras theorem, divide hypotenuse on both sides, and this hypotenuse will cancel out. We will get 1, and this will p by h. By taking square common, it will become sine square, and here we taking common, it become cos, and hypotenuse by hypotenuse square is equal to 1. So this came from so the trigonometric formula here came from this Pythagoras theorem, and it can be also derived from unit circles. See the unit circles, don't check about here, ever tried, ever failed, no matter, try again, fail again, fail better, right? So see the trigonometric formula like sine square theta plus cos square theta can also be derived from unit circle. Unit circle means a circle having a radius 1. Yeah. See, here we write a perpendicular as a, here this is a unit circle having a radius 1. Radius here is a hypotenuse, right? So perpendicular be let y, or base be x. So y equal to sine theta, because sine theta is equal to perpendicular upon hypotenuse. Here hypotenuse is 1, right? So this is why sine theta is equal to y. Similarly, cos theta is equal to base upon hypotenuse, right? So here hypotenuse is 1, so therefore cos theta is equal to x. So using this small triangle, right triangle, here we can use a Pythagoras theorem. We can apply Pythagoras theorem. So the here hypotenuse is 1 and perpendicular is x, because the perpendicular is y, base is x. So putting this, we can substitute x instead of x we can write cos theta, or instead of y we can write sin theta, right? So after this we can get sin square theta plus cos square theta is equal to 1. So it can also derive from unit circle. So my next slide here is, as you can see that wait. So my next, okay, sorry. So this is done, right? So this is also done. So this is 6 slide here. My 6th slide here is trigonometric functions. So we know that sin square theta plus cos square theta is equal to 1, right? How it came from. So by dividing both sides by cos square theta, we can also derive another formula for it, like sin square theta by cos square theta is a tan square theta, and cos square theta by cos square theta is equal to 1. So it conveys that 1 by cos square theta is equal to sec square theta. So we can also write another formula, 1 plus tan square theta is equal to sec square theta, right? So my next my next slide here is also we can divide this function, this equation by sin square theta as well. Before we did from cos square theta, so here we did divide by sin square theta, and we get sin square theta by sin square theta is 1, and then cos square theta by sin square theta is equal to cot square theta. 1 by sin square theta is equal to cosec square theta. So we get 1 plus cot square theta is equal to cosec square theta. This is also a formula. So see, the main formula here is a sin bracket a plus b is equal to sin a cos b plus cos a sin b, or cos bracket a plus b is equal to cos a cos b minus sin a sin b. This is very important formula, one of the most important formula in trigonometric function, right? See, it can be proved from Euler equation. See, what Euler equation says is e to the power iota theta is equal to cos theta plus iota sin theta, right? So instead of theta we substitute a plus b here. So wherever there is a theta we substitute a plus b. Okay. So it can be expressed as e to the power iota a into e to the power iota b, because we know that e square can be written as e to the power into e to the power 1. The power become add, we get 2, right? Similar in this way, this can be do like this, right? So right hand side we remain like this, and then solving these two terms, e to the power iota a can be expressed as cos a plus iota sin a, and e to the power iota b is expressed as cos b plus iota sin b, right? So by solving this we can we get iota square is equal to minus, so we make this iota terms, we erase this iota time because iota square is equal to minus 1. So we take a real term together. So we real term together we get what? See, real term together is cos a cos b minus sin a sin b, which is here real term is cos bracket a plus b, right? So we compare this left hand side and right hand side, we get cos bracket a plus b is equal to cos a cos b minus sin a sin b, and we compare imaginary term sin bracket a plus b is equal to sin a cos b plus cos a sin b. So from here Euler series we get this two formula, which is here I written. So yeah, so important is, if you don't understand the concept, read again. If you still don't understand the concept, read again. If you still don't understand then concept, call me, it's my number. It's for something like job. Okay, now my next slide here is, okay, where is, okay, now Euler series is done, right? Okay, sorry, this is double slash I put. Okay, now next slide here is, okay, with these two formula, why this is why this formula is important, I will tell you. Here, right, a is equal to b. If we write a is equal to b, then sin a b is equal to become a, right? So sin a plus sin bracket a plus a is equal to sin 2a, which is also equal to sin a cos, in terms of b we write a, okay, sin a cos a sin a, which is same, right? 2 into 3 is equal to 3 into 2, right? So this means sin a cos a is equal to cos a sin a. So we can say